So you've got a Kafka topic. You've got a stream of events. Now I'm showing my stream of events as a kind of chronological timeline here, with earlier events towards the left and more recent events towards the right. And you want to process these events, but you want to do that in a stateful way, in a time-based way, a temporal way. Now, one way you can do this is by using windows. You can define a span of time, and you can collect all events that have a timestamp that would put them in the same span of time, in the same window. You can collect them together and then process all of the events that fit in that window. Now, a window, depending on what kind of app or solution you're building, that could be a minute, it could be an hour, it could be a day. Maybe you want to calculate something based on all of the events that occur within a minute. Now, what that calculation is, again, will depend on the kind of application or solution you're building. Maybe you want to find the biggest value of all the events that have occurred within a day. Maybe you want to find the average value from all of the events that have happened within a minute. Now, this can work really nicely, but recently I've seen a few people get tripped up by some of the subtleties and nuances of windows. So in this session, what I want to do is to try and explain exactly how windows behave. Which events will be included in which windows, which events will be included in the results from windows, and when those results will be emitted, and which events maybe won't be included in the results at all. So let's get started. Now, I'm going to keep this nice and simple, and for my flow, I'm going to count how many events I see in 10-second windows. Now, I've started making my flow here already. I'm going to be processing events that look like this, really small JSON payloads that have a timestamp field. And I'm going to use that timestamp field as the source of my event time. Now, like I say, for this flow, what I'm going to do is count how many events are produced to the topic in 10-second windows. And I'm going to keep it to 10 seconds just because it's nice and small and you can see it happening. So to do a count, I'm going to use an aggregate node. So let me set that up now. I'm going to give it a friendly name, count events in 10-second windows. I need to define the size of my window, so I'm going to set this to 10 seconds. I need to define what computation I want to do. Like I say, I could be looking for the biggest value from the events in the window, or the smallest, or the average, and so on. But I'm going to keep it really simple and just count how many events I see in each 10-second window. And this is going to be my output, so let's give it some names. Number of events in 10-second window. This is going to be the timestamp for the start of my window, and this is going to be the timestamp for the end of my window. And I don't need the result. Right, that's enough for my flow. Let me start that running. And actually, I'm going to drag that up just so that we have lots of room for the results. Make that a bit bigger. There we go. Let's put that there. So that you can see what's happening, I'm going to run a Kafka consumer over here in this window on the left. So you can see all of the events that are being produced to the topic and alongside the results that are coming out of the windows. And while I'm producing the topics, before I produce each event to the topic, I'll add comments to explain what's coming. So I'll do that inline as here, so you can see exactly what's going on. So let's get started. Maybe my first event is going to have a timestamp a little after midnight. So we'll put it in a window that is, say, 10 seconds past midnight. So it's got a timestamp that is somewhere between 10 seconds and 20 seconds past midnight. So let's be really clear. This is a window that will close when there is an event with a timestamp at or after 20 seconds past midnight. So let me produce my first event to this topic, and maybe it's got a timestamp of 11 seconds past. Notice I'm using timestamps with dates that are many, many years in the future. I'm doing that intentionally. I really want to make the point that this processing is based on the property in the payload in the event on the Kafka topic. It's got nothing to do with real-world time, with what you sometimes hear described as wall time or clock time. If you look at this here, we're talking about 10-second windows. I've been talking for more than 10 seconds, and you haven't seen any results yet. This window is going to close not in 10 seconds from now, this window will close only after there is an event on the topic with a timestamp that is after then. Let's keep going and you'll see that happen. Maybe the next event on the topic has a timestamp of 17 seconds past. Still fits within the window. Let's move forward a bit. Maybe the next event we'll see on this topic is going to be a little bit later. It will fit in the next window from 20 seconds past to 30 seconds past. Let me save myself some typing. I'll copy this reminder just to say that we'll see this window close only after an event with a timestamp after 30 seconds past. So maybe the next event is at 22 seconds. So what's happened? This event has a timestamp of 22 seconds past. That is after 20. That means this window can now close. This window is closed, so we've taken all of the events that we've collected in this window and performed our computation on them. In this case, all we're doing is counting, so it's nice and simple. So we've counted these two events, and you're seeing that in the results here. Two events in the window from 10 seconds to 20 seconds past. Let's keep going. Let's see a couple more events at 23 seconds, and then one at 27 seconds. Let's jump forward a little bit more. Maybe the next event we're going to see on this topic will be a little bit later. Timestamp between 30 and 40 seconds. So let's copy that reminder. This window will only close after we see an event with a timestamp after 40 seconds past. So the next event maybe is going to have a timestamp like 36 seconds past. So quick recap, what have we seen happen there? This timestamp of 36 seconds is after 30. That means this window has now closed. We've taken all of the events that we've collected in that window, the three of them, we've counted them, and you're seeing that result show up here. There have been 3 events in the window from 20 to 30 seconds. Now, so far, all of the events that I've shown you have had increasing timestamps. And I didn't actually need to do that. You know, maybe the next event on this topic could have a timestamp of 33 seconds past. You know, it goes back a little bit. That is totally fine. This timestamp still nicely fits within this window. So it's okay for us to collect that in this open window. It can still be collected together, ready to be processed when this window closes. The other thing, I've shown you so far all events that have unique, distinct, different timestamps. I didn't need to do that either. So maybe the next event also has a timestamp of 33, and the next one after that as well. That's totally fine. Even with duplicates, even with them being out of sequence, all of these events have got timestamps that fit within this window. So it's okay for us to collect them, ready to do our computation. And let me show you that in action by moving forward again. The next window from 40 to 50 seconds past. This is a window that will close when we see an event with a timestamp in the payload after 50 seconds past. So let me produce another event. This one may be with a timestamp of, say, 42 seconds past. So what has this done? Because this 42 is after 40, this window is now closed. We've taken all of those events, even though they were out of sequence, even though there were duplicate timestamps in there, we've collected all of those events together, and that's why you're seeing this 4 events between 30 and 40 seconds. Let me jump forward a bit. I'll explain why in just a moment. So maybe the next window is going to be from 13 minutes and 10 seconds. Still a 10-second window, so that'll be to 13 minutes and 20 seconds. And this is going to be a window that will close only after we see an event with a timestamp after that 13:20. So to see events in this window, they're going to have timestamps something like, say, 13:15. And maybe the next one after that could be 13:17. So let's move forward a bit, and then I'll explain why I've done that. So the next window after that is from 13:20 to 13:30. 13:30. There we go. So this event could have a timestamp. The next event on the topic could have a timestamp like this, 13:22. Now, what has happened? This event of 1322 is after 1320, so it's closed this window, and we've seen that show up as the 2. But what I really want to show you was there's a long time gap in between 50 seconds past and this 13 minutes past, but you're not seeing lots of windows with a result of 0. We don't create windows just to fill in the gaps. A window is only opened, a window is started only when there is an event on the Kafka topic with a timestamp that is later than any of the previous open windows. And that window is closed only after we see an event on the topic with a timestamp that is after the end of the span that causes it to close. We don't create other windows to fill in the gaps where there are missing events or anything like that. We start a new window, we collect all the events, we close the window when we see the last event. But what happens if events arrive even outside of that? What happens if we see late events? So by that I mean events that have timestamps that would fit in windows that have already closed. So let's think of an example of this. So maybe an event that would fit in this first window between 10 and 20 seconds past. So maybe the next event on this topic has a timestamp of 13 seconds past. That is too late. This window is already closed. This window, we are only going to move forwards. We're only going to create new windows, and this window has closed. We're not going to emit a result for that window again. So that window is not, this event, this latest event, is not going to be included in the results that we're emitting in this flow. Let me show you another example. Maybe the next event has a timestamp of 25 seconds past midnight. So that would have put it in that window, but it's too late. That window is closed. We've already emitted the results for that window. We're not going to go back and recompute the results. And just for completeness, let me do another one for the next window along, between 30 and 40 seconds, with a new event here that could have gone in this window, but it's arrived too late. We've moved on. And to show you, let me do one last event at 1 a.m. So this new event is after 13:30. So this most recent event has closed this window because that window was still open all the time we were receiving these late events because we were waiting for an event that was after 13:30. This latest event is after 13:30, so this window has closed. So this window from 13:20 to 13:30 has now showed up here. And our one event, this one event here, is what we've counted here. So that's the basics of how windows work. But we can make it a little more complex. So let me show you that next. And the complexity comes from when we need to deal with late events. And I showed you a little bit about late events there, but what happens if events can arrive even later? So let me go back into how I configured my source of events here on this topic. So this event lateness field, I left at 0. But what if you want to wait for later events to arrive? This property here, you can use this to add some extra time to the end of the windows. It gives you time to wait before you close the windows in case any late events arrive. So maybe I'm going to make this 1 minute. I'm going to wait for an extra minute after the end of a window before I close it to allow time for late events to arrive. Still going to be a 10-second window. I'm just going to wait for an extra minute before I close it. Hopefully this will make sense when I show you this running. So I'm still dealing with 10-second windows, but actually let me give this a name. 1 minute lateness. I just need to click through this again. There we go. So I'm going to start that running. Okay. So let's start a new window. So actually let me start at the top here so it's easier to see. So I'm going to start a new window. Let's go from 10 a.m. 10 seconds past. So 20 seconds passed. Now, this is going to be a bit different to before. This window is for events that have timestamps that fit between 10 and 20 seconds. But this window will only be closed when there is an event with a timestamp at or after 10:01:20. That's 1 minute after the end of the window, because we're using 1 minute lateness. Let's see that in action. So maybe the next event on this topic has got a timestamp in it of 10, maybe say 11 seconds past. So that fits in that window. And let's have another event as well, maybe at 13 seconds past. Okay, so let's move on a bit. We'll move on to the next window. From 20 seconds past to 30 seconds past. But we are dealing with lateness, so let's remind ourselves. This window is only going to close when there is an event with a timestamp at or after 10:01:30, because that is 1 minute after the end of the window. So let's see some events produced to the topic now. So let's go with something like 27. And remember, like I was saying before, these events don't have to come in order as long as they fit within the window. So maybe the next one is 22 seconds, and the next one after that is 21. None of these events have got timestamps that are after that. So that is why we haven't closed this window yet. We've actually now got two windows open at the same time. We're collecting windows in two separate windows. We're collecting events in two separate groups, and both of them will be closed at a different time. Let's move on a little bit more. Let's jump forward a bit so we can see things start to close. So we'll go from 40 seconds to 50 seconds. And again, I think this reminder is helpful when we're dealing with lateness. So we're talking about a window that will close only after we see an event with a timestamp after 1 minute after the end of the window. So let's see some events on the topic here. Say 43 seconds, 45, 46, 47. Notice, and this is where people start to get confused. You know, we've seen many events spanning multiple windows, but we've seen no results be emitted yet. That's because all of these windows are still open. All of these windows are waiting for possible late events. None of these windows have closed, and you only see results when a window closes. So let's see that actually happen. Let's jump forward a little bit more so we see an event that will cause a window to close. Let's jump forward to the next event is going to be at 10:01. So that's going to be a window that's going to close only after we see an event with a timestamp at or after that, 02:30. So what timestamp could this event have? Let's say 10:01:21. So what's happened? This event has had a timestamp of 10:01:21. That is after 10:01:20. So we've now been able to close this first window. We've collected two events in it so far, so that's what you're seeing counting here. Between 10 and 20 seconds past, we received two events, and that's been emitted as a result. Let's move forward a little bit more. 10:01:30. Notice I've still got two open windows. This one is still open, ready, and could receive new results, late results. This window is still open and could receive late results. And so is this one, actually. 10:01:30 to 10:01:40. This window will only close when we see an event on the topic that contains a timestamp at or after 10:02:40, 1 minute after the closing of the end of the window. So let's produce a new event. We'll give this one a timestamp of 01:33. So what's happened here? This event, 01:33, has a timestamp that is after that. That has meant we've now been able to close this window. We've collected three events in there, and that's why you're seeing this result of 3 in the window between 20 and 30 seconds. Now how do we deal with late events? Well, let's start with late events similar to the ones we looked at before, late events that are too late. Too late. So this is going to be events with timestamps that would fit in windows that have already closed. So we've closed 2 windows. You can see the results here. So what happens if we got an event on the topic that contain a timestamp that would have fit in either of those windows? So we see an event at 15 seconds past. That would have gone in this first window, but we've already emitted the results for that. We're not going to go backwards, we can only move forwards. So we're not going to recompute the results for that window. This latest event is not going to be included in the results that we emit. Let me show you one more example. Maybe if the next event on the topic contained a timestamp of 23 seconds past, that would have fit in this second window, but that window is already closed, so it's too late, and we're not going to be including that in the results. But because we have that lateness of 1 minute, we can deal with some late events. So let's look at some others. These are going to be late events with timestamps that fit in windows that are still open. So what kinds of events am I talking about here? Well, maybe the next event has a timestamp of 41 seconds past. That would put it inside this window. This window is still open. This window is waiting for us to see an event with a timestamp of 10:01:50. We haven't seen any events with a timestamp that late yet, so that window is still open and can still keep accepting new events. So that's going to be added into that previous set of 4. Let's see another event. Maybe the next event on the topic has a timestamp of 10:01:25. That would put it in this window. This window is also still open, still also available to accept new events in it that we can collect, because that's waiting until we see an event like that. We haven't seen anything that late yet, so that window is still open, able to accept results. Let's keep producing events to this topic. 26, 27. Let's see that being emitted in some results. If I produce an event to this topic with a much later timestamp of midday, let's see what happens. That has closed several windows. So you may have noticed 3 new results be emitted just because of this one latest event. Because this latest event of 12 o'clock was later than 02:40 and it was later than 10:02:30. It caused all of these windows to be closed at the same time and all of the results to be emitted. And what results did we get? Well, between 40 and 50, that's this window here, we got a result of 5. That was the 4 events that I originally produced, but also that late one that came in then. That one was added to the list. And this next window here, from 01:20 to 01:30, that's this window here. It had that result I produced at the time, but also it picked up those 3 new late results that I produced afterwards, were collected in to that result of 4. So this is where people start to get confused, because they're waiting to see their results. They don't see their results being emitted yet because they've perhaps added lateness into their event source. And that means those windows are still remaining open, waiting for possible late events. And then sometimes they see an event with a much later timestamp, and from that one event being produced, they suddenly see several results being emitted because that one late event suddenly closed several windows and they see all the results of those previously open windows. Hopefully this demo has helped to make sense a little bit of how windows work. Hopefully this has helped you think about how you can use this in your solution. It is a really powerful technology, a really powerful technique, but you need to think about how you're going to use this, particularly if you have a Kafka topic where events are not being frequently emitted. Because if you don't have a new event on the topic that's able to close a previous window, you're always going to be waiting for the events in that previous window, for the results from that window to be produced.